So we have the next question on the board, question number 7. Now, which of these is slash are true? Roman figure 1, mass is a vector quantity. Roman figure 2, mass is constant. Roman figure 3, mass is measured with spring balance. However, these are the option. Option A, I only. Option B, Roman figure 2 only. Option C, Roman figure 3 only. Option D, Roman figure 2 and 3. So these are the options now. So you can answer, pause the video, try to answer it, then play again to see if you're correct. Now, you should understand matter, because the topic we are doing here is actually a particulate nature of matter, questions around matter and changes matter undergo. Now, we should know that matter is anything that has mass, occupies space, and can be perceived. So what is mass? Mass is the quantity of matter an object contains. However, people, or students rather, mistake mass for weight. Now, mass and weight are two different quantities. So, however, we are going to look at the difference between mass and weight before we can answer this question. So, we are going to look at difference between mass and weight. In the tabular form, mass and weight. Now, the first one we should know that mass is the quantity of matter an object contain. Now, if you have a pen there or you have a biro there, the quantity of matter that pen contain or your book contain is the mass of that book or pen, respectively. What is weight? Weight is the force due to gravity on an object. The force due to gravity on an object. So if I have an object and this is the mass, so the force of gravity acting on the mass, will give us the weight. So weight here is equal to mass times gravity. So mass is the quantity of matter an object contains. Weight is the force due to gravity on an object. Now the next one is mass is constant or fixed. Now weight varies or changes. Now, I'm going to explain this. Now your mass anywhere is your mass everywhere. So your mass in this part of the world is equal to your mass any part of the world. Mass does not change. But however, weight varies because gravity changes from place to place. Now, for example, you should know that weight is actually dependent on mass and gravity. But for you, since your mass rather is constant, weight is equal to mass times gravity, right? Now, for you, I'm talking about any object or you precisely. Now, since your mass is constant, we are going to remove it from this equation. Now, weight is equal to gravity. Now, if weight is equal to gravity, what are we trying to say here? That your weight is directly proportional to gravity. So, if the gravity on you increases, your weight. So if the gravity on you increases, your weight will increase. If the gravity on you or any object decreases, the weight of you or that object will decrease. So take note. So gravity has a way of affecting. Gravity affects the weight of an object directly. Now take note of this. Now the value of gravity on the moon is equal to 1/8 the gravity of the earth. The gravity on the moon is equal to 1/8 the gravity of the earth. That means the gravity on the moon, or the gravity of the moon, is reduced or it's decreased by 1/8 compared to that of the Earth. So your weight on Earth is actually different from your weight in the moon, because the the gravity of the Earth. So your weight on Earth is 1/8 greater than your weight on the moon. Okay, so the next thing we are going to look at is mass is a scalar quantity. The scalar quantity. Now, while weight is a vector quantity. Now, mass being a scalar quantity means it has magnitude but no direction. Magnitude means we can actually assign a value for it. You can be 30 kg, you can be 50 kg, you can be 10 kg. However, this does not portray direction. There's no direction when it comes to mass. However, weight is a vector quantity, so it has both magnitude and direction. You can weigh 40 Newton, you can weigh 30 Newton. However, there's a direction for weight. The direction is equal to the direction of gravity. So the weight, your weight is acting towards the downward direction. So weight has both magnitude and direction. So we assign it as a what? A vector quantity. Then the next we are going to look at now is that mass, the SI unit for mass is gram. Now, gram is the basic SI unit for mass. However, if you want to measure large mass, you use what? A large prefix, which is kilogram, right? Kilogram is usually used for larger mass, right? But the basic unit for mass is gram. In chemistry, we use gram because we work with little mass. So the basic unit of mass in chemistry is gram. But for physics, we use kilogram because we are dealing with larger mass in physics compared to in chemistry. However, for weight, the SI unit is Newton. Newton. Why is it Newton? Because weight is a force. Then we should also know that mass is measured with beam or chemical balance. Beam or chemical balance. While weight is measured with spring balance. While weight is measured with what? Spring balance. So if you know all this and you want to put all this down, please pause this video, then write it down, then play again. So with this, we can actually answer this question. From here, Roman figure 1, mass is a vector quantity. Check, is mass a vector quantity? No, mass is a scalar quantity. So Roman figure 1 is out of it. Now, weight is constant. Is weight constant? Sorry, mass is constant. Is mass constant? Let's see. Yes, mass is fixed. Mass does not change. Okay, mass is measured with spring balance. Is that true? That is not true. Mass is measured with beam or chemical balance. Option A, 1 only. Mass is a vector quantity. That's not true. Option B, mass is constant. That is true. Option C, mass is measured with spring balance. That is not true. Option D, 2 correct, 3 wrong. So the answer is not A, the answer is not C, the answer is not D, the answer is B. All right, so I want to clean the board now, so we forge ahead. Now the next question, which is question number 8. Question number 8. Let's go there. Which is not a direct effect of condensation? Which is not a direct effect of condensation? Option A, we have dew. Option B, we have cloud. Option C, we have fog. Option D, we have rain. So you put down this as I clean the board. If I were you, don't joke with any of my topical videos. You will see how it will help you in the exam. So now, let's see this question. Which of these, or which is not a direct effect of condensation? Now, one thing you should know, what is condensation? Condensation, when gas turns to liquid, the term mainly used is condensation. However, two phenomena can convert gas to liquid. Two phenomena can convert gas to liquid. Take note of that. One is condensation. The other is liquefaction. In the course of this class, I'm going to explain these two, but however, we are going to deal with this first. From the question, which of these is not a direct effect of condensation? Condensation is when we convert gas to liquid. We convert gaseous state of a substance to liquid of the substance. Now, during the day where the temperature is high, now all water body or any water surrounding you, with being river, sea, ocean, the little water in your cup, the water in your basin, your drum, evaporates. Once they evaporate, they turn to gas. However, at night where the temperature is relatively colder or where everywhere is cool, this water vapor that evaporates during the day will start to condense, will start to turn back to liquid. Now, once they turn back to liquid, they form droplets of water on surfaces or objects like your car. Once you wake up in the morning, you see, go to the car, you discover that droplets of water are seen on the car. Those droplets of water, due to condensation of water vapor at night, is what we call dew. Are you seeing it now? So dew is a direct effect of what? Condensation. Now, at night too, when the temperature is colder and this water vapor in the atmosphere condense to liquid water, once they suspend in air, they are usually called fog. So these droplets of water suspended in air are called fog. Most times, when you wake up in the morning, it looks like you see cloud, like it's like smoke. Yes, you see it in mostly in cities. You see something like it's like cloud, not that cloud, like smoke. Most times it becomes dense that you can't even see the next person on the other part of the road. So when this droplet of water suspend in air, it is called what? Fog. However, droplet of water formed in the atmosphere is called cloud. Now, it means that dew, cloud, fog, and rain are all effects of condensation. But however, only one is not a direct effect of condensation, and that one is rain. I'm going to prove it to you. I'll show it to you. Now, when evaporation occurs and this water starts to evaporate, it forms cloud in the atmosphere. Up the atmosphere, it forms cloud here. Now, one thing you should know, that if this is cloud is water droplets due to condensation. Cloud contain little water droplets. Now, with time, these water droplets start to combine with each other. This will combine with this, and becomes very big. This will combine with this, and become very big, very big, very big. When these water droplets combine with each other and become very big, the cloud will now be too heavy to carry this water droplet. Then this water droplet falls back as rain. So we can see that rain is not a direct effect of condensation. Cloud is a direct effect of condensation. Rain is when the cloud is too heavy and the water droplet in the cloud falls back as what? As rain. So the option is not dew. The option is not cloud. The option is not fog. The answer is rain. The answer is rain. So put it down. So we move to the next question. Question number 9. I'm cleaning. You have to write. If you've not written what I wrote on the board, just play back, pause, and write. Then we'll move to the next question, which is question number 9. Question number 9. The SI unit of mass is option A. We have Newton. Option B, we have joules. Option C, we have calories or calorie. Option D, we have none of the above. Now, in the previous question we just did, we looked at the difference between mass and weight. And I said, one, mass is the quantity of matter an object contains. Weight is the force due to an object. Mass is constant. Weight varies. The unit for mass is gram, while the unit for weight is Newton. Now, mass is measured with beam or chemical balance. Weight is measured with what? With spring balance. I gave you the SI unit for these two guys. So the question here, what is the SI unit for mass? The SI unit for mass. The SI unit for mass is not Newton. Newton is the SI unit for force. Joules is not joules, option B. Joules is the SI unit for either heat or energy. Now, calorie, it is not calorie. Calorie is also the SI unit for energy or heat. So the answer here is none of the above. The answer is none of the above. So quickly, we move to the next question, which is question number 10. Question number 10. The conversion of solid states directly to gas is called option A, condensation. Option B, deposition. Option C, sublimation. Option D, vaporization. So this is a simple question. We ask the conversion of solid states directly to gas is called. Now, condensation is the conversion of gas to liquid. Yes. Deposition is the conversion of gas to solid directly without passing through the liquid state. Vaporization is the conversion of liquid to gas, which can be done by either evaporation or boiling. You recall, sublimation is the direct conversion of solid state to gas. Now you understand that, or you've seen camphor. Now camphor is sublime, right? Yes. Now if you have a large ball of camphor that is as huge as this camphor. Now you drop it anywhere, majorly in the restroom. After some time or some days, the size of the camphor will reduce. Now what just happened? The camphor at that point is solid. Now it begins to sublime, turn from solid to gas directly. So we are going to look at what we call phase transition. Phase transition. Now matter will change from one state to another, either by application of heat or extraction of heat. So solid will turn to liquid, liquid will turn to gas. If I heat up a solid to some extent, it melts and gives us what? Liquid by heating. If I heat up what? Liquid to a certain extent, it turns to gas. This is done by heating. However, if I cool a gas to a certain extent, it condenses and turns to liquid. If I cool a liquid to a certain extent, it what? It freezes and turns to solid. So one factor or one external factor used in phase transition to transform or transit one state of matter to another rather is heat, application of heat or extraction of heat. Now to turn solid to liquid, to turn a more dense state of matter to a less dense state of matter, most cases we apply heat. If you turn a liquid, which is a more dense matter than gas, to a less dense matter, we are going to apply heat. To do the reverse, we extract heat. So if we have liquid here, solid here, then gas here. Now everything here can actually undergo phase transition, can turn from one state to another. So solid can turn to liquid, liquid in turn can turn to solid, right? Liquid can turn to gas, gas can also transit to liquid. Solid can turn directly to gas, gas can turn directly to solid. So now there are various terms used for this phase transition which I want you to know. Now solid turns to liquid. When solid turns to liquid, we say it undergoes melting. We call it melting or fusion. That's the other name, melting or fusion. When liquid turns to solid, we use the term used is what? Freezing. Freezing or solidifying. Good. When liquid turns to gas, liquid to gas, we use the word vaporization, which occur in two ways: evaporation and boiling. When gas turns to liquid, it's two terms we can use, but in most cases you have to use this is the most common, condensation. However, there's another way which you can convert gas to liquid, which is actually different from condensation. That is liquefaction. Liquefaction is different from condensation. However, they all do the same thing, convert gas to liquid. Now, when solid turns to gas directly without passing through the liquid state, the term used is sublimation. Sublimation. Then when gas turns directly to solid, yes, if I get this camphor, this camphor that turns to gas, if I can capture the gas, I can actually convert it to solid back by using a cold inverted funnel. So when gas turns to solid, the term used is deposition. But some writer or books will tell you is reversed sublimation, which is also okay. So with this now, we can actually answer this question. The conversion of solid state directly to gas, solid state to gas, it is not condensation, it is not deposition, it is not vaporization. The answer is sublimation.